Welcome to today's lesson on metallic bonding. This is a fundamental concept in chemistry that explains why metals have their unique properties. By the end of this lesson, you will understand how metallic bonding works and why it is important. Atoms form bonds to achieve a more stable arrangement. In chemistry, we study three main types of bonding: ionic bonding, covalent bonding, and metallic bonding. Today, we are focusing on metallic bonding, which is unique to metals. Metallic bonding occurs in pure metals and alloys. In this bonding, metals lose their outer electrons, forming positive ions. These electrons become delocalized, meaning they are free to move throughout the structure. The result is a lattice of positive ions held together by a sea of delocalized electrons. Exam tip: remember, in metallic bonding, the attraction is between positive ions and delocalized electrons, not between two atoms directly. Here we see a simplified diagram of metallic bonding. The circles represent positive metal ions arranged in a regular lattice. The small dots represent delocalized electrons that can move freely throughout the structure. This arrangement gives metals their special properties. Let's take a look at the properties of metals. Number 1. High melting and boiling points. The metallic bond is very strong, so metals usually have high melting and boiling points. It takes a lot of energy to break the attraction between positive ions and delocalized electrons. In exams, when asked about melting points, always mention that strong metallic bonds require lots of energy to overcome. Next is conductivity. Metals also conduct electricity because the delocalized electrons are free to move and carry charge through the structure. Students, in your answers, always remember to mention delocalized electrons when explaining why metals conduct electricity. In addition, metals are also good conductors of heat, since the delocalized electrons transfer energy quickly through the lattice. Metals are also malleable and ductile. This means they can be hammered into sheets or drawn into wires. Why is this possible? The layers of positive ions in the giant lattice can slide over each other. But the sea of delocalized electrons holds the structure together, so the metal does not break. Let's compare the melting points of sodium and magnesium. Sodium has a melting point of 98 degrees Celsius, while magnesium has a much higher melting point of 650 degrees Celsius. This is because magnesium has 2 delocalized electrons per atom, compared to sodium with just 1. The stronger attraction in magnesium requires more energy to break. Exam tip: always relate melting point differences to the number of delocalized electrons and the strength of metallic bonding. Most metals we use are not pure but are in the form of alloys. An alloy is a mixture of metals, or a metal mixed with a small amount of another element. Alloys are usually harder than pure metals because the different-sized atoms distort the regular layers, making it harder for them to slide over each other. Let's take a look at this IGCSE exam past questions. Question 1A I says describe the bonding in a metallic element such as sodium. You may include a diagram as part of your answer. Question 1I says describe how solid sodium conducts electricity. You can pause and give it a try. Here are the answers to the questions. Let's take a look at another exam-style question. The boxes give two properties of metallic compounds and possible explanations for these properties. Draw one straight line from each property to the correct explanation. Here are the answers to the questions. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with ACE students. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.